Hello guys, welcome to Aviation World. Please subscribe to the channel and enjoy the video. The Instrument Landing System, ILS, is a radio navigation system that provides short-range guidance to aircraft to allow them to approach a runway at night or in bad weather. In its original form, it allows an aircraft to approach until it is 200 feet over the ground, within a half mile of the runway. At that point, the runway should be visible to the pilot. If it is not, they perform a missed approach. Bringing the aircraft this close to the runway dramatically improves the weather conditions in which a safe landing can be made. ILS uses two directional radio signals: the localizer, 108 to 112 MHz frequency, which provides horizontal guidance, and the gyroscope, 329.15 to 335 MHz frequency, for vertical guidance. The relationship between the aircraft's position and these signals is displayed on an aircraft instrument, often additional pointers in the attitude indicator. The pilot attempts to maneuver the aircraft to keep these indicators centered while they approach the runway to the decision height. Optional markers provide distance information as the approach proceeds, including the middle marker placed close to the position of the decision height. ILS may also include high-intensity lighting at the end of the runways. Using ILS, an instrument approach procedure chart, or approach plate, is published for each ILS approach to provide the information needed to fly an ILS approach during Instrument Flight Rules (IFR) operations. A chart includes the radio frequencies used by the ILS components or navids, and the prescribed minimum visibility requirements. An aircraft approaching a runway is guided by the ILS receivers in the aircraft by performing modulation depth comparisons. Many aircraft can route signals into the autopilot to fly the approach automatically. Localizer. A localizer is an antenna array normally located beyond the departure end of the runway, and generally consists of several pairs of directional antennas. The localizer will allow the aircraft to turn and match the aircraft with the runway. After that, the pilots will activate approach phase. Glide slope, GS. The pilot controls the aircraft so that the glide slope indicator remains centered on the display to ensure the aircraft is following the glide path of approximately 3 degrees above ground level to remain above obstructions and reach the runway at the proper touchdown point. Limitations. Due to the complexity of ILS localizer and glide slope systems, there are some limitations. Localizer systems are sensitive to obstructions in the signal broadcast area, such as large buildings or hangars. Glide slope systems are also limited by the terrain in front of the glide slope antennas. If terrain is sloping or uneven, reflections can create an uneven glide path, causing unwanted needle deflections. Additionally, since the ILS signals are pointed in one direction by the positioning of the arrays, glide slope supports only straight-line approaches with a constant angle of descent. Installation of an ILS can be costly because of siting criteria and the complexity of the antenna system. ILS critical areas and ILS sensitive areas are established to avoid hazardous reflections that would affect the radiated signal. The location of these critical areas can prevent aircraft from using certain taxiways, leading to delays in takeoffs, increased hold times, and increased separation between aircraft. Identification. In addition to the previously mentioned navigational signals, the localizer provides for ILS facility identification by periodically transmitting a 1020 Hz Morse code identification signal. For example, the ILS for runway 4R at John F. Kennedy International Airport transmits IJFK to identify itself, while runway 4L is known as IHEC. This lets users know the facility is operating normally and that they are tuned to the correct ILS. The glide slope station transmits no identification signal, so ILS equipment relies on the localizer for identification. Monitoring. It is essential that any failure of the ILS to provide safe guidance be detected immediately by the pilot. To achieve this, monitors continually assess the vital characteristics of the transmissions. If any significant deviation beyond strict limits is detected, either the ILS is automatically switched off, or the navigation and identification components are removed from the carrier. Either of these actions will activate an indication, failure flag, on the instruments of an aircraft using the ILS. Marker beacons. On some installations, marker beacons operating at a carrier frequency of 75 MHz are provided. When a transmission from a marker beacon is received, it activates an indicator on the pilot's instrument panel, and the tone of the beacon is audible to the pilot. The distance from the runway at which this indication should be received is published in the documentation for that approach, together with the height at which the aircraft should be if correctly established on the aisles. This provides a check on the correct function of the glide slope. In modern aisles installations, a DME is installed, co-located with the aisles, to augment or replace marker beacons. A DME continuously displays the aircraft's distance to the runway. DME, Distance Measuring Equipment, DME, provides pilots with a slant range measurement of distance to the runway in nautical miles. DMEs are augmenting or replacing markers in many installations. The DME provides more accurate and continuous monitoring of correct progress on the aisle's glide slope to the pilot, and does not require an installation outside the airport boundary. When used in conjunction with an aisles, the DME is often sited midway between the reciprocal runway thresholds with the internal delay modified so that one unit can provide distance information to either runway threshold. For approaches where a DME is specified in lieu of marker beacons, DME required is noted on the instrument approach procedure, and the aircraft must have at least one operating DME unit, or an IFR-approved GPS system to begin the approach. Aisles categories. Smaller aircraft generally are equipped to fly only at Cat 1 aisles. On larger aircraft, these approaches typically are controlled by the flight control system with the flight crew providing supervision. Cat 1 relies only on altimeter indications for decision height, whereas Cat 2 and Cat 3 approaches use radio altimeter to determine decision height. Thank you for watching this video. If you like this video, make sure to hit the like button and subscribe to the channel.